All right, so I'll walk you through a demo. We'll take a look at the UI just briefly, and then what I really want to show you is our ability to handle mixed workloads and deliver that consistent type of performance that we've been talking about. All of this, MPIO into the front, the way that we distribute the load, this is what then the end result is. So you see here, this is the dashboard on the GUI. Top left, check marks usually indicate that things are going okay. If there is a problem with a component, you'll get a link there. On the right is a snapshot of, or a real time of what your performance is, which isn't very much right now. On the left, one of the advantages of having just a single storage pool, whether it's 1K block or 4K blocks, is that our customers are concerned about only one utilization number, essentially, is how much used capacity is there out there. So we give them this graph on the left there that shows them over time how they're trending and actually using capacity. This is after thin provisioning, dedupe, and compression. Speaking of those, you see in the center, you're provisioned, you're allocated, and then after allocation, after dedupe compression, your physical storage. This particular system has a mixture of databases, general purpose virtualization, and some VDI on it. So we're getting about 7-to-1. And finally, along the bottom, just some quick links to get to your host groups, volume groups, and your event log. Now, I won't walk you through every single one. We'll see the performance tab extensively here in a minute when I start running some load. But you'll notice at the top is your throughput, the middle is your IOPS, latency at the bottom. We'll break out the block sizes that we're seeing, which I find most administrators like to know what kind of block sizes are coming in, and your reads versus writes. Of course, there's an event log. You can manage your hosts and host groups and volumes through this interface. The snapshots, which we'll come back to at the end, we'll run a snapshot in an active system, demonstrate that there's no performance impact. You'll see in that particular one will be this Oracle database, so we'll see that number. You might notice it go from 1 to 2. The system tab, I like to tell people this is about all I need to know to install the system. Need a couple of IP addresses, default gateway, subnet mask. DNS servers are usually helpful, and an SMTP server for sending alerts. The administrator also can come to this page to get numerically more detail on the physical usage, provisioning, snapshots, replicas, etc.
So you say snapshots, just curiously, max number of snapshots that you may have?
Maximum number of snapshots per system?
Per volume? Per system? Both, any maximums, and can you delete snapshots out of order? Because I know that question would follow.
Okay, so
is there a maximum, and if so,
there's always
so the maximum is determined by what we are testing. So we don't really have a maximum in the way we build architecture.
It's like the largest number.
Today we certified 8,000 snapshots.
That's not bad.
And 32 per volume. Of course, we will continue to expand these numbers. Regarding the flexibility of the snapshot, so you can delete any snapshots. You can restore to any one of the snapshots without losing other snapshots. This is a differentiation that we have. Not everybody are able to do it.
That's why I ask, because
so it's very important to have the flexibility to restore from a specific snapshot, and if it's not good because some crash consistency and the database doesn't like it, then you can just go to application consistent snapshot and go to it. So I think this is something that our customer really likes.
And you then have, because it's application consistent snapshot, plugins that integrate with stuff.
Yes.
Be it vCenter or stuff like that.
We have a VSS provider for Microsoft. We support the full suite of VAI.
You have a vCenter plugin, as in this is accessible inside their web interface versus the fat client that we all prefer?
It's the web interface for the vCenter plugin. That's correct. Okay, so a couple other things just quickly on the system side. You can see your ports. We can see our connections from the hosts. Pull these up, and if we're doing some troubleshooting, we can see all worldwide names. The inventory. This is the system that we're playing with here in the lab. Is a 2K block system with a single shelf each, so you can see the health of all the components that we're tracking. So the K block, as we've been discussing, contains 2 nodes. The nodes have the 2 battery backup units to protect the RAM. 2 power supplies, and then each node itself has 2 SSDs and a RAID 1 for the local operating system. So we can see that all of those are healthy. Then there is the shelf itself that's part of the block, 2 expanders, 2 power supplies, and all the 24 drives. And of course, they're all showing green right now. And as I mentioned, should there be a component issue, you'd have that shortcut link there on the homepage to come over to view it.
Projection for VVOL support?
I'll let him answer.
So yes, we are part of the program of VVOL. In the next few months we'll do it. So it's not like a month from now, but we believe this is the right time for our customers.
Cool. Okay, but VVOL support's going to require substantially more than 8K.
This is why I said that we are, this is things that we are already testing and improving the qualification. But
you don't have a hard limit like others.
We build the system from the ground up. So it's not that we build a system that is good for a small number of entities. We build it upfront for large number of entities, and now we just need to test the scale of the system.
All right, so I'm going to do 3 different workloads for you, and then we're going to mix them up. So the first workload is an OLTP. This is a random select out of a 100 million row database. So the purpose of this is to generate small block random IO, high reads. I have 2 Oracle servers running. Incidentally, one of these is running against a replica. So you're going to see we're not compromising in performance based on replicas, which are writable snapshots.
Not across.
So we're going to run 2 of these simultaneously. You see when I launched the first one, I hit about 62,000 IOPS there. We're going about 0.3 milliseconds.
Okay.
So as the other one comes on, we're going to double that performance. So now we're running at 110 or so thousand IOPS, a third of a millisecond of latency. You can see our block sizes are less than 8K. So this is a small block workload, 100% read. This is that sort of consistency that you might expect, like, okay, here's your small block random IO. I think you would expect that to be pretty good. So cranking along about 127,000 IOPS. This runs for about 60 seconds.
Dustin, can you scroll a bit down so you can see?
Oh yeah, sorry about that.
I think it's...
Do you have a quality of service features of some kind?
Sorry?
Quality of service.
Okay, so we are focused on enterprise and private cloud. We are not focused on public cloud. In general, customer in the public cloud would like to limit the maximum performance of the system. And it's also related to the way the system is architected. If the system is not fully balanced, so the data and the metadata of every volume is not spread evenly across all nodes, you can easily reach a problem that one application in one volume is killing the performance of the application. There are other vendors that are not distributing the metadata across all nodes, so you can get into a situation that one application is killing the performance of the cluster. Because we believe in full distribution, for us it's much less critical to add the quality of service, because the system, we cannot have one application that is completely killing the cluster unless it's reaching the maximum limit of the system. Of course, we will add it in the future, but it's not our first priority now.
So, no.
That's a no then, I think.
Yeah.
No. But I want to explain, because it is important, because there are architectures that are not balanced. If I can give an example, the leader of in that space, SolidFire, build a very nice quality of service solution, but customer must use it. Why is that? Is because they are not spreading the metadata across all nodes. For specific volume, the metadata reside in one node. So you can easily kill the performance of the cluster with one application. So this is very critical to understand. So of course, there are scenarios where you gain value from public cloud, for instance. You can gain value from it. But if you are forced to define the quality of service, it means that it is much more complex for an enterprise customer. They don't need it because the system is very balanced.
So for an enterprise customer, if I have a critical workload like, let's say, SAP,
okay,
I'll get equally bad performance when the system has contention as Exchange.
I think that this is why we are using this demo. We are showing a system with running multiple workloads simultaneously, very high load, very high IOPS, very high throughput, and the performance is very, very consistent without doing any tweak to the system.
So at some point, every system reaches its max. So I think the question is, when this system reaches its max capacity, there's no way to prioritize workloads over one over another.
So we do not see many customers reaching these limits, and normally they scale out. Of course, you can get into this scenario. We do not support quality of service today. We will add it in the future. But yes, it's not like #1 priority for us. And this is what we hear from customers. It's not that.
Okay. So do you support replication or mirroring across clusters, across so from like Chicago to New York or something like that?
Our replication will be ready in like a few months. It's already working in the lab, and for the first few customers are using it.
Asynchronous?
Asynchronous. In addition, we have a partnership with few third-party vendors.
I'm sorry?
We have partnership with a few third-party vendors to do replication, so we are delivering solutions for our customer for replication from our side. And in addition, we'll soon have the replication, native replication. So we have a solution now, and we'll have a native solution, asynchronous replication, within a few months.
Okay.
All right.
So in the case of you're saying, hey, we're not going to experience a lot of contention in types of situations like that, we don't see that in the example here, but this is a two workloads that are operating in a pure read capacity, or at least when you ran it.
They're not going to be, I promise.
Okay, cool. Because the initial wave was all read.
Yeah, I'm doing
great.
I wanted to do the easy stuff first. Okay.
Break it.
And what I
no, seriously.
Okay,
this is the room to break it.
You will see.
Oh, I'm going to
try. You will see 4 or 5 gigabytes per second as part of this demo.
So let me go ahead and start it while we're talking, because it runs for about a minute. So this is an ETL workload. So you're going to see at the beginning a 50-50 mix roughly. We're reading off files and we're loading it into a database table. About 45 seconds in, what you'll see is a large set of all reads where we're doing a simulation of verifying the load that we've just done. So this is 2 servers doing this exact same load. We can see here that we're doing 3.5 gigabytes per second at 50.
See on the right side there too, the little chart that's moving around.
Yeah, right here.
Does it peak at 6,400 megabits per second, or gig? Is that the peak point? It can't go above that from a throughput, from an I/O?
Just a second. I'm just stalling because it'll get bigger in a second.
Sure. Yeah. I mean, but that is our ceiling, at least for this stack.
For this particular test, what we usually find to maximize the system, you need enough horsepower.
Yeah.
The numbers that we publish, it can hit those very easily. It takes at least 2 hosts with probably 4 fiber channel ports apiece to maximize what 2K blocks can do.
Sure.
But see, you can see here at the end when we're doing our reads, this is 4.6 or so. The 2K blocks, if you ran just a benchmark 100% read at it, it would be 6.4 gigabytes per second.
Cool.
So we're well within the limitations of what the system can do.
What do you attribute the latency spikes to in that workload?
Sorry?
Latency spikes to me would be a bit of an extreme.
You'd have to go back if you scroll back.
So what we're talking about differences between 0.8 and 1.2. I don't really consider those latency spikes per se.
And also it's a large I/O. It's not like 4K. It's some of the I/O is like 128K and above. Okay.
Yeah, so the smaller latencies with smaller block sizes are, of course, because you're moving less data. Larger block sizes, you move more.
So, for instance, your latency spiked right there to 4 milliseconds. What was the story?
There were probably 20,000 I/Os in there. I don't know why those one particular ones were any slower than the others. Yeah, this is so. What I just did right now in this particular system is I booted.
The IOPS didn't peak there. I mean, Yeah, I don't know. Okay.
So what I started here was 23 virtual servers. These are all Windows 2008. Each one, when they started up, picked a random profile of a workload to run. There's a couple of different choices, but it's a mix between reads and writes, different block sizes, sequential and random. Now what this I want to show you is a simulation of your general purpose systems that are running on here while you're also doing all this other load. So you can see we put a baseline on here, 15,000 IOPS. The latency gets a little higher just because we are pushing it as hard as we can. So now what I'm going to do is throw in the OLTP, which we already discussed was a lot of reads, and then I'm going to run the OLAP on the other one. If I can type. So now I'm running ETL. I'm running small block queries off a database, and at the same time, I'm running 23 different servers doing a general purpose workload. And we're doing all of them with latency, that's hovering around between 0.5 and a millisecond. Obviously with some ranging in there depending on...
Now what's the capacity of this? So it's 22% capacity used, is that what that says?
Yes. This is a 2K block system, so it's either 45 or 90 terabytes. I'm not sure what size drives this one has.
Okay.
A 2K block system.
2K blocks, two shells, four nodes.
That's been a contention. When you say 2K block, we're thinking you're talking about 2K blocks, 4K blocks, like reads and writes. 2K, 4K.
No, I know.
No, and that's...
I don't work in marketing, and I didn't name them, so...
No, and it's and we can wait, this is 2K. So we're running this as a 2K workload, but in 64K chunks. Or
it's definitely no 2K workload I've ever seen.
Yeah.
But yeah. So yes, it's 2 Kaminario K blocks, 4 nodes, 2 shells, 48 drives.
That helps.
Yes. And it's 4 nodes. All right.
Okay, you want to do the snapshot maybe now?
Of course. Sorry, get distracted. Last thing.
Oh, it's 1 more minute, sorry.
Yeah, one more thing is we'll go ahead and run this one more time, and I'll do the snapshots at the same time.
What's the burden on snapshot deletion? I delete all my snapshots. I delete one snapshot that was early in the cycle.
So because we are using log structure array, we are doing reclamation always. Because when you are writing the new data, you are claiming the old data. So there is no real difference between the reclamation when deleting a snapshot and the reclamation in just normal pass. And all our specs of performance are with reclamation and with system that is 85% full. Okay.
Cool.
Okay. So I took a snapshot right about here. You'd notice the system didn't fall down when we took that snapshot. So we can come over here and see the one I mentioned previously, the Oracle volumes each now have a backup that was created in the local time of this system, 1154. So that was just, again, to show you what we said we could do, which was take snapshots without performance impact.
If you were to take a snapshot of all the volumes?
Yes, it's one consistency group.
Yeah,
same no blip, really, right?
Yeah, so actually the snapshots are done at a volume group level. A volume group is a container for volumes. It also acts as a consistency group.
So we
done at a volume group level?
At a volume group level.
Yeah, it's a consistency group.
It's a consistency group.
Okay, the number of operation to create a snapshot.
You could actually snapshot a single volume if you wanted to, if you just had a consistency group with that volume in it, right?
Sorry? I'm not sure I follow.
You can actually snapshot a single volume.
So you can do for one volume as well. Okay. Now I think what is very important to explain, we do not have like bitmaps to set. And creating a snapshot is like 2 or 3 constant number of operations. That's to set a timestamp. That's all. So this is why it's so fast. Yes, the speed of creating a snapshot is like a speed of an high operation. And this is why it was able to show you a snapshot creation without any impact on performance. We don't have like long query time of half a second like others have.
How come your IOP, your latency spiked there? You weren't even doing anything.
The system's running about 15,000 IOPS. I don't know why there's that one particular.
Do you only offer the GUI? Do you have REST API? Or
yeah, there's a RESTful API. There's a CLI that's very comprehensive as well. lots of tab completion and context help in it. So depending on whether I get customers who prefer only GUIs, we've got the GUI. You got the customers who only want command line, we got that too. And then you got the ones that want to program everything. So I think we've got them all covered.
So thank you,
right,
Dustin. Just to recap, I hope you appreciate the deep dive into our unique architecture. As I said, we're very proud of our unique architecture that allows customers the flexibility to scale out and scale up with an adaptive block size. And it all comes down to, at the end of the day, how easy it is to scale with us, and how cost efficient it is to scale with us. And with that, I want to thank everyone for your participation. And the guys are still alive, so that's thank you, thank you for that. So
Thank you.
Haven't killed anybody yet this year.
yes, only this
You
year.
aren't over yet.
But it's still
It's early in 2015. No, thank you very much.
Thank you.
Thank you.